All right, so in this problem here, I'm going to skip quickly through number 3, A and B, and you can see that we have our vertex here at 1, 5, and 3, 13 is on the graph. But what I really want to talk about is C, D, and E. Okay, and so it undergoes a reflection over the y-axis, then a horizontal translation 3 to the right, and a vertical stretch by 2. So if we go step by step, I know at this point 1, 5 will reflect it over the y-axis. It means it will end up over here at negative 1, 5. And 3, 13 will become over here to negative 3, 13. When I then take it and translate it to the right 3 units, and this is going to go over 1, 2, 3 to here to 0, 13. And negative 1, 5 will go over 1, 2, 3 to 2, comma 5. And then when a vertical stretch of scale factor 2 means the y value gets multiplied by 2. So now I'm going to go 0 to 26 times 2. So I'm way up here at 0, 26. And 2, 5 will multiply times 2. And I'll go up here to 2, comma 10. And so my graph ends up being like this. And based upon that, I can find the equation. I know that y is equal to, I'm not sure about the horizontal stretch or vertical stretch altogether, but I do know it's going to be x minus 2 squared plus 10 because of the vertex. And if I want to find what a is, I use this point here, so 26 is equal to a x 0 minus 2 squared plus 10, which will be 16 is equal to negative 2 squared is 4a, and so a is 4. And so I get y is equal to 4x minus 2 squared plus 10. Okay, and that's using the idea of the transformations, keeping track of the points, and then building the equation from our transformations. That is how we could do C part. Now E part says to verify by transforming the equation. Well, if we consider that, I want to pull this down here so I can see it a little bit better. And so I know I have the initial equation, which I'll redefine as f of x is equal to 2x minus 1 squared plus 5. And then the first thing I'm going to do is I'm going to do a reflection. And when I do a reflection over the y-axis, that means I'm going to make this function here. I'm going to reflect f of x over the y-axis. Then I'm going to translate my function. I'm going to translate r. I'm going to translate r to the right 3. So I'm going to take it and I'm going to shift it to the right, so it's opposite sign 3. And then I'm going to take a vertical stretch. I'm going to take my t function, and if the vertical stretch by a scale factor of 2, I'm going to multiply t of x times 2. And now I'm just going to go and build my function overall. So I can then say r of x is going to be 2, plug my negative in, negative x minus 1 squared plus 5. And then r of x, to find t of x, I take x minus 3 and I plug it into r, which will be 2 minus x minus 3 minus 1 squared plus 5, which I simplify that to 2 minus x plus 3 minus 1 plus 3 minus 1 is 2 squared plus 5. And then finally, to find v of x, my final one, I multiply t of x times 2. Everything gets multiplied times 2, each term. And so when I do that, I end up with 4 minus x plus 2 squared plus 10. Now, I recognize that that is not quite the same as what I had up here. Okay, so if I think about this, I'm going to pull out inside the parentheses negative out, and I get x minus 2 squared plus 10. And now if I square this negative 1, it becomes x minus 2 squared plus 10.
And so whether I do it with transformations or if I do it by graphically, by building the function from the transfer, by following the points, I end up with the same function at the end.